Hey,
Hello?
hi, how are you?
I'm good. Can you hear me well?
Yep, yep.
Perfect. All right. So this is a system design interview, right?
Mm-hmm.
Great. Yeah, we have an hour together. So I have a question prepared. And so I think the plan is that we can do a 40 to 45 minute interview. And then after that, I'll give you some feedback. And then we'll do some Q&A at the end. How does that sound?
Yeah, cool.
Cool. Okay. So I have a question, and if you don't like it, let me know. We can always switch it up to something else. But here it goes. Um, I'd like you to design the back end of a system that allows you to donate to a list of charities. So back end system that allows you to donate to a list of charities. Does that make sense?
Mm-hmm. Yeah, yeah, sounds cool. Mm-hmm. Okay, so backend system that allows you to donate a list of charities.
Yeah.
Um, Let me think on that. So yeah, we building just the backend system and list of charities. Is it like hard coded in our system or it's dynamic and we can add it?
That's a good question. Let's assume that the list is prepared, right? And
Mm-hmm.
so it's like a hard-coded list already available, so you just have to load it up once, right? You don't have to
Mm-hmm.
design a system to accept that.
Okay. Okay, cool. Also that allows you to donate, allows to, I mean, how actually as an end user I would donate to this system. So I have some kind of UI where I like select my, select the charity, where I want to donate and select amount of money and just press the donate, something like that.
Uh, yeah, so that's a good question too. How does that work? Well, I would say that yeah, the user in the front end would decide how much money they want to donate, and they would decide which charity they pick to donate to, and they can donate to the same charity multiple times,
Okay.
and they should be able to donate whenever they feel like it, right? They should be able to donate every 5 minutes if they want, kind of thing. So that's the kind of flexibility you want the service to have.
Yeah, yeah, agree on that. Cool. Cool. So let me think. And also, yeah, that's clear. Also, what about the payments? Do I need to like care about the payment system, or I can just use like third-party service?
That's a very good question too. Um, what we care about here is if you can get the job done. So if you think there's something out there that exists that you can leverage, by all means, it's up to you. If you feel like you need to do it yourself and not trust other third parties like Stripe or others, then by all means design that too. But the choice is up to you. And ideally, if you could explain the decision of why you chose one or the other, that would be great.
Mm-hmm. Okay, cool. So yeah, that's clear. So select payment uh, strategy, strategies, something like that. Cool. That's clear, I think. Now, like, I have the understanding of the system that I want to build. And yeah, at the finals, where let's say I got the money, so I represent kind of like middleware, right? So uh, when what is my question is, for example, we have a charity X, and we receive donations like each 5 minutes. Should we like each 5 minutes move all the money to this charity, or like collect this and move it once a day or once a week? What's our strategy would be here?
Um, I would say this is up to you.
Mm-hmm.
Um, if you want to be real time, uh, You could, but I think for this problem, let's just say this backend system does not need to send the money to the actual charity until maybe once a month or something. So
Okay.
you could hold on to the data for a little bit, if that helps.
Okay. Yeah, absolutely makes sense. So how my let's say how data for a month. So let's say something like that. Like oops. Like depends, something like that. Okay, so yeah, I think this is all about requirements. Now, yeah, now this is great. Now let's think about data that we want to get here. So let's say I'm not sure about about the number of users that do the donations. So I'm not that kind of familiar with this stuff, but let's say that we would have like 10 um, and yeah, I assume it should be a worldwide service. So okay.
Yeah, I think that's a good assumption.
And let's say worldwide we receive like 1 million donations per day. I think it's donations per day. It should be something around. I'm not sure, but it seems like they're a good number that we can start off and then just work on that.
Yeah.
So if we have 1 million donations, in day we have like around 86,000. Let's say we have 100,000 seconds. So we would have like 10 requests per second, something like this. Am I correct?
Yeah, very close. Very close. I can give you a good conversion here. 1 million per day is roughly 12 per second. That's something to remember. And another one that I like to use is 5 years is about 2,000 days.
Yeah, awesome.
These are good things to remember.
Yeah, cool. Thanks. Yeah, really helpful. So okay, we have 12 requests per day and per second. I mean, 12 requests and what else we want to estimate? So yeah, what kind of data we would like to store in our system? So I think let's call data. So we would, I think users could be anonymous or not anonymous, yeah, with our donations, but still we want to store some kind of ID for users. So if user is anonymous, probably we would generate some kind of random ID. But if user would like to not be anonymous, he would probably sign up in our system, and we would have an ID in our system for him. So we will store that kind of information. Then probably like amount of money, let's call it amount, right? Then the how to say charity ID probably to which he donated, he or she, and the amount, well, probably date, maybe some kind of message. I'm not sure if that's like and some kind of other metadata, but the most crucial for our part is here, something like that. And let's say for ID we would have something around like 12 bytes, like 6 characters, something like that, 12 or more. For amount, let's say 2. For the charity ID, let's say it also will be 12 to here, and here it's like, I don't know, the message could be big, right? So let's say 12 to 20 bytes, something like that. And if you round it up, let's say that the whole 50 bytes for 50 bytes per donations, and we have 12 per second. So I could say donations, and so 50 times 12, it would be 600 bytes per second. It would be our bandwidth, and per second, and again we do it times 100, so like it's 2 more zeros. So we have like 60 million bytes, which is 16 megabytes per day, and if we times it, let's say 2,000 days, right? We would have uh, 12, 112, and then three more. Uh, it would be like this. So it would be 120 gigabytes for 5 years for storing this data, something like around like this. So I think it's pretty much it for our high-level estimations. Yeah. Now let's proceed to the second problem. Let's think about the payment strategy. So what I think is handle payments is pretty tough, and our system should be like we need to put a lot of effort to make it secure and so on. It would cost a lot of effort. So probably it would be much easier to like use a third party service for doing this kind of payments, like you mentioned before, like Stripe or something like that. And uh, I think it would be safer for us. And in the long term, if and yeah, and probably one more step that we would save a lot of money for development here and maintaining such kind of system. So like uh, to manage high availability and consistency of a payment service is not a trivial task. So yeah, I think for the start, it's better always use for the payment processing some kind of provider. And in the future, when we would have like resources and we would see that we could actually develop our own, we could change it. But for the
Yep.
start, I would say that we would use a Stripe or something like that.
Yep.
Uh, yeah, cool. So yeah, that's okay. Now, so again, this is the process. User select charity, push amount the money. So I think now we should draw a high-level design, yeah, how it would work. So I would switch to the draw part. Yeah, cool. So let's imagine that here, and so yeah, we built in the backend. Okay, cool. So let's say that here is our client, all right? So he, oops, should be this one. So he calls our backend, and let me think, we have 12 per second. It's not actually that much if you think about it, but I will add it because in the future, if we would like to scale, for sure uh, we would like to have some kind of layer of load balancers, and let's say we would have a server here. It would be a replication server, which will uh, yeah, it would be a replication server. Now it receives the information that about like user wants to donate amount of money. Then we would like to um, be sure like to log. I'm not sure how this works. This money stuff. What I mean is like he decided to pay. Probably we want. So if we transfer money once a month, so it should be, or uh, in which point of time do we want to do a withdrawal? Like uh, once a month when we want to like transfer money to donations, we should withdraw all users' account like in this time, or each time a user decided to pay, we should withdraw it right away and store in some like middle account. Uh, which
Are you asking whether the money comes out of the donator account right away, or does it come out of their account once a month? Is that the question?
I mean, should I store somewhere this, like, should this transfer be right away? I mean, do we need any middle account to store users' money, or we do it like from users' account
Okay.
to donation?
Yeah. I think the answer here is it's up to you how you
Mhm.
want to handle the intermediate money. because it's up to you how you want to send the money to the charities, right?
Mm-hmm.
But one thing you you want to do here though is whenever a user says they want to donate the money and they click that button and say yes, I donate amount of money, that money is going to be out of their account right away, right?
Mm-hmm.
So now I think it's very natural to say there's an intermediate account for your service to hold on to the money for a while until end of the month or end of the week to send that money out. And that's not really the important part of this system here. Um,
Mm-hmm.
so you're free to kind of decide how you want to do this.
Okay. Okay. Cool. So yeah, and I know the payment service have some kind of feature where you can just block the money, like not withdraw them right away, but like block them and user will not be able to use them. So we could use some kind of that. So yeah, I'm just the part what I'm thinking right now is on how to move money. Uh, the way to do it to not lost this process. So okay, when the app receives the information, so let's say somewhere here, we would have the database with all this data stored there. So we like push that this user decided to transfer this amount of money to this one, to this donation service. Um, we store this data. Now let me think what would be the best way to do it. So if I do, okay, let's say we do it right away. So we have a list of payments, like accounts of our donation services. So we can just initiate the transaction in this moment, user pays, and just move this money to the donation service, and that's probably it. So let's say here we would have the uh, mm, PS, it would be payment service provider, right? Our application would initiate the transaction here for moving the money, and our client need to approve it. So when he approves it, we just move money to the like charity. Let's say this here would be some kind of abstract, the charity bank account. So it moves like here from the payment service provider, like this, something like that. Yeah, and we store the history in the database of what changing. Let me think if I'm not. So now it seems not something not. Mm-hmm. So what if something goes wrong? What could go wrong? Yeah, here. Our application server could go down. That's not a huge problem because we could just power on multiple instances of it. For the case of failover, just to change them. The same for, as I said, we would not store a lot of data, so probably uh, for the database we could use the plain SQL database. It would be it would fit the whole data in one source. So as we said, for the 5 years we need just 120 gigabytes, so it would fit in on one machine pretty easily. Just for the sake of availability of our service, we could do replication, uh, like replication of our database. If in case if one instance fails, we could use another one, read and write. So we could use a strategy something like master slave, right? Um, yeah, and we think. So do we? Yeah, I think I see now. If user like initiate the transaction to the application, like sends the request that he wants to donate, but application server dies in that moment when it receives the request, but still not send it to the payment service provider. Like in the middle of that, if server dies. Um, that's the problem here. So probably we would like to have some kind of message queue here. Uh,
Where's the message queue? Can you draw the message queue?
yeah, I think, so I think we need to present here one more service here. So when user pushes the initiates the transaction here, we push it to the application, and application puts it to the message queue. Let's say something here. We would redraw everything. So he pushes it, or she pushes it to the message queue. Here let's call it queue, and only after that we return the success like response to the user. So we know that we would not lose the data about his desire to do donations. And so the message queue would then, like here we would have the, why am I drawing it not in the right direction? So here would be servers that do like all this payment stuff, all right? And it would actually talk with the third-party providers and so on. And yeah, probably I would like to delete this. It's so small, like this. So yeah, I would like to delete here. Yeah, and make it more like this. So it pushes it here to the payment service. Here we have some kind of third-party provider, the previous one that I just cleared, and that's it. So like that, I think it would be more stable. And for messaging queue, we could use something like Kafka, uh, RabbitMQ, something like that.
Okay.
Yeah. And
So let me try to understand this part a little bit with the queue. So this part here, can you explain what is this? Is it a service or is this a database or what is this payment here? Can you explain this box?
yeah, it would be our service that handles the payments. So it initiates a transaction, like it talks to. It's a microservice that would be responsible for handling all the payments, and that's all of its responsibility. Why I decided to move it from the application service to like for application service be responsible for maybe some kind of like, I don't know, the client side there would be or some kind of another request talking to the database, and I want to like split the responsibility to those services.
Okay. So, question about the app service here. If I understand your diagram here correctly, is this true that in the app service here, it is writing a copy to the database, storing the metadata. At the same time, it is putting an item in the queue so that the payment service here will go and actually talk to the payment service to get them to validate the transaction. So these two things are synchronous, right? Writing the record to the database to store a transaction history, as well as performing the actual transaction to the third-party service. Is that right?
Yeah, that's a nice notice that that's the
Yeah,
right.
because the question here is what happens if one of these two things fail? Does that mean that we have a inconsistent state of the system now? If one of these two things fail, could be a network failure, could be the third party went down. You know what I mean? Like if one of these things fail, what happens, and how do you handle that?
Yeah, that's a great question. So I need to certainly think more about that. So I need to write to have in the like status for the payment that I initiated. And when user just like with the synchronous action, we not just add it to database, but we set its status to initiate it, something like that. And after, and then we have like three different directions, right? User could cancel the payment. User can just do nothing about it, just forgot about it, and user can't actually pay, and it would be successfully stated. So from the start, it would just put it there with the status initiated, and after payment, uh, application. Let me think. Yeah, yeah. So the payment service would know about the status of the payment. So when payment service responds that hey, we actually received money from the user, we should ping our application service and say, hey, the status of this payment is successful, update the database. And yeah, something like this. So we would have statuses for this.
Okay. Okay. Yeah, that makes sense. All right. So, next question I have is, let's say your service becomes very popular. So instead of 1 million users per day, you have 1 billion donations per day, right, across the
Mm-hmm.
world and all that. So given this new um, load of users coming in, how would you change your design to handle the growth?
Yeah, that's a very good question because and it uh, puts a lot of questions on the table, right? Because uh, and from the engineering standpoint and from the like payment providers, are they available in all the countries that we want to like spread on and so on. But if we like put that aside and just focus on the engineering part, um, I would say that we like the simplest part, like let's imagine that we started in the US, right? So and we have our data center there. So the simplest that we can do is start just by scaling horizontally, increase the number of application servers, do more replicas of the database, and that's it. But when our data like we stored now not 120 gigabytes but like terabytes of data, we should certainly think about the sharding. Yeah, and here I think I would shard the data just based on the, let me think, actually users ID. If they donate anonymously, they would be generated. Hmm.
Yeah. Uh,
Yeah,
so you mentioned using a SQL database in the beginning, right? Can you explain how you would shard the data in using a SQL database?
yeah, that's what I'm thinking right now. So if we have not 120 gigabytes but like terabytes of data, uh, now I'm thinking that maybe it would be even easier to use some kind of NoSQL solution. Because
Okay. Yeah,
if
let's say you
if
use a NoSQL, right? So
mhm.
how would you scale that database? Yeah, that's a good follow up here. How would you scale your NoSQL database?
Yeah, I would yeah, as I said before, I would do sharding, and now I think on which key should I do the shards. If we have like donation services, we could do it based on the like let's say we have 10 replicas, uh, and we just take hash of we would have some kind of hash function which, based on the donation service, would generate ID of the service of the shard server ID and just put data there. But if some donation service would be more popular than others, we would have hotspots on some services. So yeah, probably it's better to do it on user ID. So we would generate them by ourselves. So they would be randomly, random generated, so it should be pretty random distributed amongst all of our shards. Yeah, I would take, I would do shards based on user ID. Yeah.
But does that address the question you just mentioned, being the hard partition, where if a user keeps donating money, right, that still generates a hard partition, right? Um, how do you address that?
That's a nice point. Let me think about that more. So, how probably. Let me think. Yeah, that's a good one. So what else do we have there? We have a amount, charity, data, message. What if we? So here I think I have two solutions. The first one is not like it, just like the split when we see that our servers become really big, our shard grow. We could just split it by two, and yeah, and just split the data, like move the data. But that's not the greatest solution. Else what could we do? No, I think, yeah, I thought about doing the data, but data is always like growing. Like, what if we? Mm, no, that not would be the case. Yeah, probably I would say that we would split it by still by the user ID, and when the server like reaches some kind of amount where we are not, it's really hard, we just split it by two, and yeah, and deal with it.
Okay, so when you do get a hard partition, you split that data. That's the point. That's the solution here, right?
Yeah. So for example,
Okay.
we had a partition like from A to K, and we see that hey, it's too hard. Let's split it from A to D and to D to K, or something like that. Yeah.
Okay. 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 Um, that sounds fair. Next question I have is again in the payment microservice here that you mentioned. So let me just kind of draw this again. Um, so as you scale your service with 1 billion calls per day, do you need to change this microservice, or do you just have one microservice that will process 1 billion requests a day?
Yeah, that's a good one. Certainly, we would not. I think it would not be able to process the billion just one machine, and
Yeah.
maybe
So
not.
what is the solution here?
Mm-hmm.
To scale this part.
Yeah. Uh, so yeah, we could just put the load balancer between like yeah, we could represent a lot of those. We could just scale it horizontally, put a lot of microservices, and do. Yeah, let me think about the strategy of doing it. So I would, if you don't mind, I would like delete all of this here for now.
Yeah. Or you can how about this? Draw it below. Draw the new one below. So just keep the one above. We can still talk about it later.
Okay.
I'm not sure if we can undo it. If not, then just draw the new one. That's fine too. Up to you.
Yeah, Control Z doesn't work here. Sorry.
Yeah, it doesn't. Yeah, that's okay.
Okay, let's just. Oops, it's too big. Let's say I would draw it below from the point where like we have here the queue, right? And so from the queue, we would have some kind of load balancer layers, servers, and here we would have those payment service microservices, and we have a layer of them. And so let me think on strategy, how we distribute the load between them. So probably we could use. I think just default. What if do just default? So here again, here would not be the greatest idea to split the load based on ID of the donation services, because all of them could donate like to the same service in the same point of time. But on the user ID, I think it's pretty good idea, because in one point of time, user donates probably in most of cases. It donates just once, one amount of money. So like once, even if he or she wants to do it often, it would be like once in 5 minutes. So we could do just take the again hash of user ID and like use the consistent hashing to put so the transaction of a certain user would always get to the certain payment service. Yeah, would be like processed in one same service. Yeah, and I think that would be pretty much, yeah, and then it would get back to the application service, and here we have this third-party provider. Yeah. Plus, one thing that I want to add to like the scaling globally, probably to reduce the latency. We would like to like put our data centers in different parts of globe, right? So for example, one service in the USA, one in the Europe, and one in Asia region, somewhere there in China probably, where we would have like the same structure, but there, yeah.
Okay. Okay.
Mm-hmm.
So let me try to understand this. This new service here. This is replacing the. How is this related to the queue? Is this service here reading from the queue and then calling the processing service here, the payment service? Is that what it is? Payment service?
Uh,
Is this the same thing as that?
Yeah, this one is, yeah, that's true.
Okay. And this is your microservice here, right? You have multiple copies of this, right?
Yeah, that's true.
And where is this load balancer fit? Is this going to be here, like load balancer here? Is that?
Yeah, I understood it. We cannot like like message queue needs some kind of subscriber yet to read data from here.
Right.
So probably there would be services responding for that. I just meant that yeah, like how we scale this one microservice, like payment service like this. But yeah, for sure, I should have mentioned that we need the subscriber. Mm-hmm.
Okay. A couple more questions. Since you have multiple workers here, multiple microservices, what if one of them goes down, or some of them are unhealthy, corrupted, just went down? How do you detect that, and how do you handle that?
Mm-hmm.
Like, what if something goes wrong in the microservice there?
Yeah, that's a good question. So, load balancer would let me think. Yeah, we would balance it based on this stuff. So, first of all, we would have a copies of those services ready to like snapshot of those services ready to launch. If like one server dies, we could just launch another one. That's the first part. Then how we actually detect the fail. So it could do, we could represent some kind of health check service that like when I think it's pretty common pattern in microservice architecture to have like health checker, which will be just the server who pings all the like other services like once in some period of time, let's say like once in 15 seconds, 10 seconds, or like 1 minute, to check if they are alive, and if and to say that to load balancer, like load balancer would have this information which server is actually alive, and if one dies, we just delete this ID from the like his his address from the load balancer pool of services, and we could launch another system and just add it back there. And yeah, that's
Okay. Yep, that's fair too. One last question before we kind of wrap up the interview here. You mentioned that in your schema design, there is an ID that is a random number, right? You randomly generate that ID and then you hash that into your NoSQL database, and then you try to split it as evenly as possible. I'd like to know how and where is that random ID generated in your system?
Yeah, cool. Nice question. So let me think. So as we have a billion users, that's a lot. So for the
Per day.
yeah. So for the simple for more simple solution, I would say that I would just like use like I don't know, have some kind of number and just increment it, or
And where the important question here is, where is that generated? Where is that random number?
That's a nice question. So yeah, for doing this, I think we need to present a key service. Let me think. So we could just generate based on. No, it's not the guarantee that it would be unique. Okay, let's say that I present the new service, the key service. There we would have that would like why I think this is this problem, because our system is distributed and we have a lot of application services. What I wanted to do is to have like database which where we would have like generation of keys and that's it. But like if to there could be like race condition problem, and we would give the same ID to two different users. So probably what I would like to do is to present let's say here would be the key service. I call it KS. It's so hard to do. And here at the bottom, I would draw here key S, right? So here I would actually store the key. So I would have, I have probably if we know that we would have so now I have two ideas. So if we know that we would have a billion users, we could just pre-generate all the IDs and put it to the to the database, right? And this service would be just one who talks to this this database, and he stores all the keys in the memory. So he do it with bulk select. Like he reads 10,000 keys from this database and deletes it from there, and stores them in memory. So when when application server comes to it and asks for the key, it just returns it and deletes it from a memory. So in such a way, we would prevent the duplication. And in case of fail of this key service, we could lost keys that we asked already in the database. But I think it's not really crucial, because if we use 64 symbols, 64 bits, it's to the power of 6. If we have 6 characters, it's a pretty huge number. So I think it would be okay for us to sometimes to lose this data, and the key service would be just that if one service died, there is another one waiting, already running, waiting to take the load if needed. So yeah.
Okay, I think that's fair as well. All right, so those are all the questions I have for your system. I think that would wrap up the interview part for right now. And I'm going to give you some feedback on what I saw and what I heard, and then we can do a Q&A. So before I get started, what do you think about the question, and how do you think you did?
The question, actually, I like the question. I didn't received questions before with the payment services, so it's pretty new for me. And yeah, I like it. I think it was a bit challenging, and I think in overall I did not bad. But I should have you how to say, you point me through the interview to the different directions which I should set on my own before. So for example, for these key services, yeah, and for this subscriber for the queue, like I should have said it on my own without your question. Yeah. So.
Yeah, I agree with you. I think the question is not a very typical type of question, and it's challenging because it deals with payments, deals with privacy, security, and all that stuff. And I think I agree with you. I think you did a good job too. There's a lot of areas where I think there's a lot of positives there. So let me go into detail with this. Let's start with the beginning. And I'm back into the code section there. Kind of go through everything here. So in a lot of these kind of system design questions, the question at first will be very vague by intention, right? All the questions you get are just maybe design a chat system, design this and that, and it's your job to ask a bunch of questions to clarify the problem and to scope it down to a very manageable set of features, right? And I think you did a really good job in asking questions. The great questions you asked was, do you need to handle payments, right? Because if you don't need to do it, don't do it, right? There's other services that handles it. You might as well use it. Just like a database, you don't need to create your own database to do something, right? Just use the database to do the persistent storage. Similarly, for payment as well, somebody handle it, then let the other people handle it. That was a good question. And the other good question is how often you will send that money to the charity. That's a good question as well because you don't have to do this real time. So these are good questions. A couple more you could ask, and I think you also kind of mentioned that is anonymous or not, right? I think you kind of assume that you can do both. That's okay to assume it, but it's best to kind of call it out up front, right? So that takes some time to maybe take some experience and all that to realize that, hey, do you need to know user information or not? Can this be anonymous? That's one question. The other one, kind of minor, but it's also good to think about is currency, right? And the amount in units, right? Do you accept just dollars or do you accept pennies, things like that? That can help design your database schema, right? Like, is it going to be a float or integer value? So these are things that you could ask upfront, or maybe even assume that, so that it will make your database design much clearer, right? Again, as you are designing your database, I think you put 2 bytes for the amount, but when you arrive at that part, you may say, okay, I'm going to make it simple. Always try to look for the simple solution, right? Just say US dollars only, and then to the lowest top denominator is a dollar, so there's no pennies, nothing like that. So your storage is going to be integers, right? That makes things a lot easier, right? So those are the questions. And then I think after the questions, right away you went to the data, or what I call the capacity estimation, like how much storage do you need? What is the reads per second? These are good estimations that you did. But before you went there, I suggest that you could list out the functional and non-functional requirements first. So I think the functional is pretty much how you understood the problem. Like, what do you need to do here? You need to be able to store user donation values, right? Amounts. And what else are there for this service? You have a list of predefined charities, and users can donate to multiple charities, right? So these are sort of the functional requirements, right? Pretty much what you mentioned, but it's good to kind of list them out just in case, so that just to clarify what your system does and do not do, right? Because you're not trying to build a full system here. You're trying to build the essential features. So you need to list them out and say, this is what my system will do, right? Once you list them out here, your high-level design diagrams all that will try to fit all these features in, right? Don't do too many. You can always add them in later, but don't do too many at first. But make sure you capture the most important stuff, right? Like for this service, you definitely need to store, the transactions, right? The metadata of a donation. So that's the number one thing. And then the rest you can say, oh, maybe you can return a list of history of things that you donated, but those are minor, right? If the interviewer cares about that, they will tell you to do that. If not, then you don't need to. And by the way, you did a good job by asking another question about do you need to populate the list. So if you don't ask that question, you might think you need to design that, and then you end up spending time to design something that maybe I don't care about, right? So it's always good to ask the question and then just make sure that you design just the most important part of the service here, right? So populate list of charities. The answer is you do not need to. So that's a good question to ask to kind of just reduce the scope of the problem. However, I think what's missing in the requirement is the non-functional requirements, right? Non-functional requirements is usually what we call as the SLA, or the service level agreement, or pretty much what the system promises to the user here. So things that you can consider here is the typical CAP theorem stuff, right? Like you want to have a fault tolerant system so that if something fails, which you ask the question, what happens if something fails, right? So this is what you want to do. Your system needs to be fault tolerant, right? It needs to be scalable, right? Because right now it's 1 million item donations per day. You bet that the interviewer is always going to say, let's say this is going to grow and become 1,000x. How are you going to handle that, right? That's a question that you always get asked. So your system needs to be scalable, right? Scalable, fault tolerant, highly available, right? That means that whenever I call this system needs to be able to accept my request, right? It may not be able to handle the request right away, but it has to be able to accept it, right? So a system that is highly available is one where you have your load balancer with a bunch of web services that is able to accept the request. So when you draw your diagram and you say, oh, there's a load balancer, you need to explain why there is one, right? And so if you put out at first by saying that this system needs to be highly available, then your load balancer is there to answer that question and say, okay, this load balancer is able to accept the request and route that to multiple web services that will be able to handle this request, right? So no matter how much request coming in, I have enough capacity to handle these requests to make the system highly available. So these are things you need to put down here. And then you can also say some things that are not required, right? For example, the system does not have to be data consistent, right? For example, that means that when you submit a donation, the system doesn't have to be able to handle that right away, but eventually your donation will show up, in a database or something. So this is not important, right? So consistency is not that important, right? What else is not important? Maybe latency is not that important, right? Now it's up to you. I'm saying that's not important, but you can argue and say this is very important. Then you can design a system to make it, to make it low latency. But what I mean here when I say latency is not important, I mean that when I submit a donation, I can wait a couple of seconds before you tell me that it's complete, right? I can wait, right? Now you can say, no, my system needs to be highly responsive. It needs to be, on right away. Then you can go and design that. That makes it harder, right? How do you do that? But specifying how you want the system to be designed is part of this, requirement section, right? So mention these things. Again, a lot of this is a design decision here. I'm not saying that this has to be, you have to have it low latency. But I'm saying latency is, you can afford to wait a couple of seconds. I also think this is a design decision here. Now, the others are pretty much non-negotiable, right? You need to have a system that's fault tolerant, scalable, and highly available, right? So that's what I would put non-functional. And I think these things will guide you to your high-level design later on, right? So before we go into the high-level design, let's go through a couple more things here. I think your capacity estimation is great. Once you're able to use these kind of quick conversions, you're able to do the math really quickly. However, you notice that 120 gigs in 5 years, that's really slow, very small, which is fine because the system is going to grow and you're going to have way more than that, right? It's going to be terabytes soon. But one thing you want to talk about here is not just the amount of storage to handle today's load, but you also want to say that right now it's 120, but you want to have some redundancy in your system, right? And that's something that you can also put as your non-functional, right? Redundancy. You want to make sure that if something's wrong, just like S3 and all that stuff, um, storage has multiple copies, right? So you can say I'm going to have some redundancy here in case storage node goes down, and then on top of that, I'm going to have some buffer, right, just for peak usage, right? Let's say maybe Black Friday people donate more, I'm able to handle that extra load, right? So altogether, this becomes maybe 500 gigabytes, right, for 5 years. Now, the actual number doesn't really matter. What matters is you need to consider the redundancy, the peak usage, like a little buffer room. That shows to the interviewer that you're considering the future as well, right? So just little things here in the capacity estimation. Does that everything make sense so far?
Yeah, that's awesome. Thanks.
Yeah. So normally I would suggest that once you reach this point, it's about 10 minutes of time. And I think you actually hit that. When I look at the time by 10 minutes, in fact, I think you got to here in about 5 to 10 minutes, which is good. But obviously, what was missing was the non-functional part. If you had that, I think 10 minutes is actually doable. So I think you were on a very good schedule up until at this point. And the next thing is after that, you did your database schema design, which is good because this is where you kind of use that information to help you, estimate your database storage, which is important because without the schema, you don't know how much storage you need, right? So that's all fair. Now, the thing after that, though, I suggest is to have something called API design, because after all, every backend system needs to have some sort of API or multiple APIs so that the client can call these APIs and then perform that service, right? So if you're clear about what the APIs are, it will also help you in your high-level design. So what would be the API here, right? I would say one thing would be maybe donate money. I mean, the name doesn't really matter, but you want to explain what this API does, right? And then maybe it has a user ID or some other ID, and then pretty much everything that you put here, maybe a description, a charity ID that you're donating it to, a date, yeah, that's good, or timestamp, right? And then an amount, right? So these are the basic requirements, and that's pretty much all you need here. Now, the important part about this is, do you want to make this an asynchronous or synchronous call, right? You need to explain what it means and explain why you pick one or the other, right? So asynchronous here means that when I click donate money, I don't care whether this request successful or not, but I can ID back and say, okay, my request has been acknowledged. It's now up to the system to go and process it and then tell me later on what happened, right? That's sort of the asynchronous approach. Asynchronous approach means that when I click the button, I'm sitting there and wait, right? Waiting for this to process. It could be seconds, it could be minutes, and then when it's done, then I get a response, right? If I close that browser midway through, then everything may go maybe out of sync, right? So normally for a service for a request that takes time and it's a variable time, then asynchronous request is much easier to design, because when you do a asynchronous request, you need to return maybe a donation ID here, right? Just to acknowledge that, hey, there's a request being made already. And then after that, you want to have something called get status request API, sorry, so that the user can call this donation ID and then check the status later on, right? Check the status could be like pending, running, fail, or other things, right? But that's sort of the asynchronous approach, right? The synchronous approach will be harder to actually design because you have to talk about all the different things that could go wrong here, right? So once you have the API design complete, then when you switch to the diagrams, you can really explain how does that API call will work end to end through your system, right? And I think all this here on the coding page here will provide you clarity on how the block diagrams will fit together, right? So let's switch it over to the block diagrams and talk about what you did and some of the feedback there. So you notice that when I ask you these questions about, how do you scale, how do you get the unique ID, how do you shard the database, how do you handle when a worker goes down, these are questions that are meant for a generic workflow system, right? It's not just for your service here, but they're general questions, right? Like it could apply to almost any service out there, right? And really all these kind of questions, chat system or donation system or Uber Eats, whatever, they're all pretty much similar in terms of the backend. In terms of you need a database, you need a web service, you need a load balancer, you need a queue, you need all these workers and workflow. So you need to answer these questions for almost every single design question, right? So you want to make sure that you have different types of solutions with the trade-offs. And so everything that I asked you today could apply to a different problem, right? I noticed that I'm kind of on the time. I need about 5 more minutes. Is that okay with you?
Yeah, that's awesome. If that's okay with you.
Yeah, it works for me. So I'll just need 5 more minutes to kind of finish off my feedback, and then you can ask me some questions, and then we can call that a day. Continuing my feedback here, the questions I asked are all generic type of questions for a backend system. And like you said, it's great if you could actually go through them and talk about them as you were designing it. That makes it, that is actually better than me asking you, because it shows that you are experienced, right? It shows that you are considering what could go wrong, how do you scale the system, because you even asked that question yourself in the 20-minute mark. You pretty much drew out the diagram, and then you ask yourself what could go wrong here, right? That's a good start. And I was hoping you could talk about all these different things. And it's okay if you don't talk about it, because I could probe you, I could ask you, right? Because there's so many things you can talk about. I care about a couple of things, so I would ask you those questions. But and I would ask you questions that you may not have covered. So it's okay that I ask, but it would be great if you can talk about as much of these problems as you can, right? And again, these problems are generic problems. So I think your answers are adequate in all the questions that I asked. I want to highlight a couple of things. You mentioned about the key service, right? And the key service is indeed one solution, right? Like a separate service that is responsible for generating unique keys, and then it populates it somewhere. So these keys are pre-generated, and then you just fetch it. That's cool. But if you were to do that, then maybe fetching the keys could be like a cache, so that it's not like a database, so that the access was much quicker there, right? So you can mention that. But then even the key, like anytime you draw a box, right, that box could fail. When that fails, you have to talk about how do you handle that, right? So what happens when the key service fails, which you did talk about, and then I think your answer was it's okay if you generate it ahead of time, things like that, right? So overall, I think it's a fair answer. But there are other options. You could mention other options. One option I can think of, or I had in mind, is to leverage the database, right? You mentioned about a Nosql database. So for example, Cassandra is a Nosql database. Cassandra can actually generate unique IDs, like UUID and all that. And so you can leverage the database to generate a unique ID, right? And these databases are meant to be called like with a lot of requests per second, right? So they can definitely act as the key service there, like the database. So you could have a table of just the users, right? Anytime you have a new user comes in, you just add an entry to that table, like the user table, and the return could be the actual user ID, random generated, right? So that's one option. The other question I asked you is how do you shard that database? Again, a very common question on NoSQL database. How do you shard it? You answered that question well with the user ID, right? The user ID is a good primary key to shard the database. However, a lot of these NoSQL databases allows you to have a composite key, right? Multiple columns as a key, right? And so you could use something like the user ID plus the timestamp or the day of the donation. So those two together will more likely will not have a hot partition, right? Because every day is going to be different, right? So let's say you have 1 billion requests per day, and you're not likely to have a hot partition in within a day, right? And then the next day will be a different partition already, right? Because you're using the timestamp as part of your key, right? So that's another way to address that problem of hot partition. The next thing is the workers here. You have workers that could go down, and you answered that question well with the health check. And I agree with you that normally health check is a good mechanism to keep track of the state of each worker. However, I think with the health check, you probably want to have another service called the coordinator or the manager that does the health check, right? Like I'm like the manager of all these services. I have a list, like a pool of services. I go and do health checks all the time, right? And whenever I see a worker that does not pass the health check, I terminate that service. I start a new one. So sort of like a worker here, sorry, like a manager here to do that. And this manager can monitor the queue as well. If the queue gets too large, that means I have more requests coming in. Then you can call that, hey, this manager can do the auto scaling for me, right? I can scale up more workers. I can scale it down. I can make this service more elastic, right? So these are concepts that you can mention just to demonstrate a lot of these kind of distributed systems knowledge, elasticity, and things like that, right? And what are the questions I have here? So I think these are some of the answers to the questions I asked. I only asked these three questions, right? Scalability, maybe a little bit on the scalability here. You will always get that question, right? How do you scale your system, right? Adding boxes, right, to it is the simple answer, and it's the right thing to do too, right? Adding more databases to it, next to it, right? Read-write replicas. I think you mentioned all that. That's good. The queue, if you mention something like a managed service, like SQS, for example, these things will scale for you, right? You don't have to, implement a lot of these things if you don't have to, right? Load balancers can even have multiple copies as well, right? So all these things you can just mention, right? That's the easiest answer, right? Just add more horizontal scale almost every component, right? But with horizontal scaling, there is another problem, right? There's a problem of data consistency, right? Once you have multiple databases, well, you mentioned SQL, so that's going to be harder to address the consistency problem. But when you have NoSQL, and if it's Cassandra, all you have to do is to add more nodes, right? Once you add more nodes, that's where you mentioned the consistent hashing will help. So all that will be kind of easily taken care of. So in this problem here, I think scaling it would be the easy answer here, just to add more boxes, add more resources to each component, right? So at this point, do you have any questions for me about the diagrams and the questions and answers that I provided so far?
Yeah, that's cool. I just have one question. Database for the key service, it should be like another database, not the one that they have. Yeah, I should present one more.
You could. You could have a different database, but if you think about a NoSQL database, it's really just a collection of tables. So it doesn't matter if the table is in the same database or in a different database. So in Cassandra, for example, I think the database is called key space. And so you could have one table, multiple tables. They're not related. There's no joins in a NoSQL, right? So you don't need a separate database, but you could, right? I'm not going to stop you there and say, it's not good. It adds little value to have a separate database, but you could have it. I just don't think there's a difference here. So, and really, in a high level design here, you don't need to be so detailed about a particular technology. I don't think the interviewer will fault you to say, oh, this is wrong. You cannot have a second database. I don't think that's the evaluation there. I think that the important part here is to be able to make sure your system is scalable and it works and it like all the components actually make sense. So that doesn't matter. My answer is that it doesn't matter if you have a separate database or not.
Okay, cool. That's awesome. I think that's it. I don't have much question to, so you answered everything pretty clearly. Thank you. Thank you for your time.
Yeah. So yeah, again, maybe just kind of final words here. I think you did a really good job. Like what stood out to me in this interview is the fact that you are very calm and you're able to ask a lot of good questions up front, and that really simplified the problem so much at the end. If you didn't do that, you would probably be storing customer information like credit card numbers in your database. That would be really bad, right? That would be almost an immediate fail, right? Because you don't want to design a system where you store like security information, right? So anytime you can offload that or like don't even do it, that would be best, right? And again, the idea here is leverage what's out there already, right? Part of high level design is not to reinvent the wheel. So by asking these questions, just designing the absolute minimum is the key to good engineering, the key to success in a 40-minute system design interview. So I think that's the part that stood out to me. The rest of this stuff, all the questions that I asked, again, if you are if you just kind of maybe do a little bit more research on these parts, it will apply to almost every single system design question. And so it's just going to help you tackle other questions as well. So just be a little bit more solid on those parts, and I think you'll be fine.
Cool. Thank you. That was really helpful.
Yeah. All right then. Good luck with your interviews, and thank you for using interviewing.io.
Yeah, thank you. Thank you for your time.
Yeah.
See you.
Bye.
Bye.